we've all seen this problem. If the integral from 0 to 1 of f of x dx equals 1, and the integral from 0 to 5 of f of x dx equals 4, then what is the integral from 1 to 5 of f of x dx? On the surface, it seems impossible, right? But what if I told you there's a way to solve this problem, which is so intuitive that a grade schooler could work it out? If you'd like to learn this trick to solve this problem and more, stick around! Alright, so what's the trick? Before getting into that, let me give you a name to this kind of problem. This is a problem that tests your knowledge on properties of definite integrals, a PDI problem, if you will. There are many kinds of PDI problems, but for this video, let's focus on the adjacent intervals property. Here. You see, definite integrals measure the net area under a curve f of x. And so the entire net area over a to b is equal to the sum of those above a to m and m to b. I'm using the letter m here because m is the monkey in the middle, somewhere between a and b. Now, how can you tell if a problem is a PDI problem? Well, if you're asked to solve a definite integral with an unknown function inside, like f of x, and all you know is the value of some other integral or integrals that use f of x, then you are facing a PDI problem. And how can we solve these? Right, so here's the trick. PDI problems are really just what's missing games. What's missing is a game where you can physically see a collection of objects and you know what the complete collection should look like. It's up to you to figure out what the missing piece is. For example, what if we're looking at the collection of two numbers? One number is 1, and we're missing the second number. But we know that the complete collection adds up to 4. So the missing number is clearly 3, right? Well, in fact, you just solved the impossible problem from earlier. You see, the integral from 0 to 1 of f of x dx is the number 1. And the integral from 1 to 5 of f of x dx is our missing number. Finally, the integral from 0 to 5 of f of x dx is the collection of both numbers, which add up to 4. So of course the value of the integral from 1 to 5 of f of x dx is equal to 3. Let's try one more. If the integral from -1 to 2 of g of x dx equals 3, and the integral from 0 to 2 of g of x dx equals -2, then what is the value of the integral from -1 to 0 of g of x dx? Well, the first number is missing, the second number is -2, and we see that the two numbers should add up to +3. So the number that's missing must be 5. And that's it. If you'd like to see me cover other kinds of PDI problems, let me know in the comments below. A reference of these properties is included here. Thank you for tuning in, and I'll see you in the next video. Peace!